Good evening, everyone. The time is now 7 p.m., which means it's time for another of our ongoing series of Military Aviation Museum webinars. I want to thank you all for joining us tonight. My name is Keegan Chetwynd. I'm the director of the museum here in Virginia Beach. And joining me tonight is going to be Mike Spalding. He's the museum's chief pilot. Mike and I are going to be talking about the museum's flying Bf-109G and what it's like to actually fly that airplane. Mike's going to walk us around it, describe what it feels like to get in this incredibly rare and unusual piece of flying equipment from the Second World War. Just a little bit more about Mike before we turn it over to him. Mike is a tremendous asset to our organization. He is a volunteer who has assumed the responsibilities of ensuring the safe operation of our fleet of historic aircraft. Mike works with our other pilots, who are all likewise volunteers, to ensure that they're all comfortable flying some of the world's rarest airplanes. Mike's prior presentation with us, he went into a little bit of detail about how you get the opportunity to fly these incredible airplanes and what you have to do to be able to become chief pilot in an organization like this one. Mike has over 15,000 hours of flight time and is a professional corporate pilot for a company in Norfolk. He's flown a wide range of warbirds, from TBMs and Sky Raiders to some of the more unusual things like Lockheed Lodestars and Grumman Trackers. Mike flies our de Havilland Mosquito and, of course, our Bf-109. These are some of the most rare flying airplanes in the world at the moment. So Mike is definitely a uniquely talented aviator. And so let's go ahead and turn it over to him. That's probably about enough from me. Mike, can you hear us?
Yep, loud and clear. I hope you all can hear me. Thanks for that, Keegan. I appreciate the introduction. Hello, everyone. Tonight we're going to talk about our Bf-109, which is a G model. We'll go into a little bit of the models. We won't go too much into the history of them, but just kind of touch on it and mostly on what our airplane is and how it may differ a little bit from some of the other models and variants. And then we'll pretty much just go into, like a start of a day of going out and going flying. So we'll get started. So basically just general discussion about that, pre-flight walk around, how the systems, what systems are on it and how they operate, what they operate, cockpit layouts and some pre-flight items, ground and flight characteristics. It's kind of an unusual airplane, and there's a lot of things to talk about from that point, and just some of the personal experiences kind of through the thing that I've seen in flying it. Ours is a G model, like we mentioned, and a G4. The 4 is a variant. They had quite a few variants, and the 4 was the most popular. And what made it different is it got the bigger engine, the Daimler-Benz 605 as opposed to the 601. So it had a little more horsepower. 1455 as opposed to 1194, I think it was, for the previous one. The supercharger is the big thing on this airplane. It makes a lot of noise and it makes it sound mean and evil, and it just sounds totally different than anything else that we have at the museum. Its service ceiling was 39,000. It didn't go up there too much, but there were some of them that did. I'll mention in a second about what that's about. Like a lot of those war fighters back then, they actually had a max takeoff weight, but they loaded them up higher than that, and then that was really their weight to go off to war in. One of the other big things about this airplane that most people notice is the big prop and the fat props. Like even the Focke-Wulf 190s had the same big fat props on them. They produce a lot of torque. So that's one of the issues with this airplane, while they tore more of them up on takeoff accidents and landing accidents than actually losing them in the war. And that was a big issue. Hydraulics are pretty basic on this airplane. It just operates the gear and the coolant doors. Most everything else in there is kind of manual or electric, but there's not a whole lot. But nothing. It has all sorts of little idiosyncrasies to all the systems. They're not just the straightforward type things we'd see in American airplanes. The brakes are, in this particular airplane, are modern brakes, so they're better than they had back then, but it helps a lot with the controllability of the airplane, but you still have to stay on your toes with it. They were built special for this airplane, and they work pretty good considering. The Gustav part is all the models, like the G was the Gustav, and the E models was the Emerald, and they had a name for each model. That's why we call it that. One of the big questions we get is, why is it a Bf-109 and not an ME-109? Growing up, I'd only ever heard ME-109. That's what we thought they were. But it's really a Bf-109, even though it was designed by Willie Messerschmitt. But he worked at the Bavarian Aircraft Factory as a designer for the BFW. I'm not going to try to embarrass myself and say the German word for it, and if y'all can pronounce it, feel free. But after he was allowed to purchase the company, the Bavarian Aircraft Factory, everything after that became an ME. So like the ME-262, that's why that's that. So even though Willie Messerschmitt designed the 109, it was not his company when that happened. So that's why it's actually a Bf-109. There was almost 34,000 of these 109s made, and the G was the most prevalent of them and was probably 3/4 of the total numbers that were built. There were 14 variants, like ours of 4. In the 1 through 4 variants of the G, half of them were pressurized models, where the cockpit itself was pressurized. They had an air pump on the engine that was specific just to pressurize that cockpit. It's basically the same cockpit, but they had some more things to seal it up behind the canopy, which I'll show you where that is when we get doing the walk around. But the odd number variants, the 1 and the 3, were the pressurized versions that they used for high altitude fighter, and the 2 and the 4s were the non-pressurized low level, attack fighters and whatever else they needed for on low level. So enough of that stuff. We'll just start a walk around like we're going to go fly. I usually start on the left side of the airplane where you get into the cockpit, and here I'll just talk about a couple of things that, because I won't show everything as we go, but we'll start right here at the cockpit. I usually hop up and I'll open the canopy, make sure the mags are off, and the key in the mag is out, and I'll show you about that when we get there. The tail wheel is unlocked. It has a locking tail wheel, and controls are unlocked so you can move them. And I'll hop back down, but this right here is a step. It has a door on it that's spring loaded. You just push your foot in there, and the Germans did that a lot to streamline any holes or anything that were in the airplane. That's a handhold right there. That does the same thing with your hand. So you step there, hold there, and then you have to step all the way across to this black non-skid pad. You don't want to step on the coolant doors or the fairings. So you do that. I'll hop back down and just start around here. This is the coolant doors. You see how they're split, and that's how you control it. Those are done by hydraulics. You usually set the flaps all the way down. The flap is right next to it here, and you do that just for ease of getting in and out. That's down to 40 degrees flap right now. Here's your flap indicators right here. So the first one would be all the way up, and then 20, we have 2, and then 3 would be 30, and the last one would be 40. So you just look out the window to see where your flaps are. The flaps are manual. There's a wheel in there you turn to put them down. So these coolant doors will move with the flaps and maintain the same open degrees that you have set in there. So as you start bringing those flaps up, both of these doors will come up, but that gap will stay there unless you change it to try to warm up the engine or cool it, the coolant. One quick thing, just look forward here, because when we get around here, that bottom cowl is closed, but that it does open. And I'll talk about what you do in there in a second, but I just wanted you to see that it would when we get around there. Fuel goes in right there. I'll talk about how you do that. It's not as simple as popping it open and throwing a fuel hose in there and filling it up. There's a panel right there. They pop open just to look back inside. It's pretty hollow in there. There's not much in there. Just make sure there's nothing back there, and for inspections. So if you walk around, obviously it's taxiing here, but this is just to show you what we're looking at. Aileron there with the balance tube rod there. Your normal taxi lights. Pitot tube. I walk around the front here, and there's nothing in there. Shouldn't be anything in the wheel well here. It's just canvas that covers up that whole area there. Landing gear leg and the brakes. This is where the supercharger enters. I'll show you that here in a second when we open the cowling. But basically, that's what you're looking at as you're walking around. Right here is the slats, the movable slats. You just take your hand and push them in and out. They glide on their own. They do their own thing. They're not powered in any way except by airflow. So when you get slow, they'll just come out as they need till they come out. When you're in a turn, one might be all the way out and the other one's all the way in if you're really pulling on it when you're turning. So you just want to make sure they're free and move them in and out, that they can move, because they can get stuck if you don't maintain them properly. So as we get here, you look in the engine, here's the supercharger here, the thing that makes all the pretty evil noise when it's taxiing and flying. Just want to make sure nothing's in there, nothing's flown in there or lives in there. This is a hydraulic tank here. It's fairly small. Like I was saying, that the system itself, there's not a whole lot. It just operates the gear and the coolant doors, and but that's all it needs to do it. And this is a coolant tank. There's one identical on the other side with a tube that runs across. So it's instead of having one big one, they have two small ones that share sides. Engine mount here is pretty stout. And if you also notice, this rod here on the engine mount goes right down here, and if you can draw an imaginary line, it goes right down to that gear. That was by design to try to put all the high stress parts in one place. The engine mount and the gear mount are all basically one mount down there. And it also helped by having the gear arranged this way. They could transport these airplanes on trains or however they wanted to get them there without the wings on them. They could put a lot of them on there, and basically you get there and you just put the wings back on them and hook up the coolant and the attachments from there, and it's ready to go. I have this picture here just to show you that. It's how the engine mount really is kind of braced there with the landing gear, and it's all braced there together to make it stout with the wings off of it. This is another airplane. While ours was in Germany at Mir Motors getting built, this one was there as well. Just a little bit closer of the engine and the supercharger. Spark plugs down here on the bottom. Remember, this is a inverted V12, so all the cylinders are on the bottom. So anyone that knows anything about radial engines, and you have to really be careful with the bottom cylinders that fill up with oil. Now on this one, this is your worst nightmare. All of them want to fill up with oil. So this bottom cowling right here actually drops down. It folds, it hinges out from the other side opens on this side and hinges on the other side, and the oil cooler drops down with it. And there's drains down there that the maintenance folks have to go and drain the cylinders of the oil. It actually gets to be a pretty dirty engine to operate. It makes a mess, makes it difficult to take the airplane anywhere. They were never really designed to go anywhere. They went out, did their mission, their fighter mission, and turned around and came back and landed at the same place. And they weren't really traveling anywhere and stopping and getting fuel and this thing. That's really complicated with this airplane, just even from a maintenance standpoint. And just set back a little bit farther. Here's the bottom cowling we were talking about. And that's about it from there. The
Mike,
propeller, yeah.
I think one of the things might be interesting to point out to people is that the Messerschmitt cowlings don't come all the way off the airplane necessarily. They kind of open up like the hood on a car to some extent. They're all hinged in different places and have, you know, conveniently stowed sticks that are used to hold the cowlings open. Do you maybe want to talk a little bit about that? It's kind of distinctly different from a lot of the Allied airplanes that we have in the collection.
Well, that's true. Just like this here, this is hinged there. The other side is exactly the same. And this rod right here will come up and clip up into here, so it's always there. This bottom cowling does the same thing. It hinges from the other side and drops down. And this oil cooler here goes with it. That whole oil cooler will hinge down from that side and it'll lay down there. Sorry, I don't have a good picture of that down. It's not a quick drop down. Maintenance folks really need to do it to get it done. And they weren't there at the time. The prop is this one here is actually an MT propeller, which is basically wood underneath with fiberglass on the outside. That's kind of common these days, but back then it was an alloy metal prop. But it's electric prop. It's operated by electricity, and there's a switch on the throttle. And when we get in the cockpit, I'll show you that. And it has a manual and an auto mode. It's a different operation totally than anything American or even British that I've flown. But I'll tell you more about that operation when we get ready to go fly. The landing gear.
Before we depart the engine, the airplane's fuel injected, does that translate to any material difference in operating the airplane than the sort of naturally aspirated Allied aircraft?
Yeah, yes and no. We're going to get to that, but the fuel injection system on this airplane is totally different. And if you give me 1 second, we'll get to that, and I'll show you where that is. But I want to make a point out while we're here in the front of the airplane of the gear, how the gear is attached to the fuselage, and the tires, which is another thing I know everybody notices, are really canted in. And the reason for that is they obviously didn't ask any pilots about that, because that's one of the real bugaboos about flying this airplane is those wheels being canted in that way. But that's just so when the gear folds up, it lays up flat and is at the same angle as the wing. So that's what you end up with it when it's down here. We'll talk about how that affects us flying when we get to that point, but just want to make a note of it. This is its 20 millimeter cannon, that goes through, it comes out the spinner. Let's see. Oh, sorry, that's the oil cooler right there. It kind of takes care of itself for oil cooling. It's automatic. This is the other side. There's the other coolant tank I was telling you about. The fuel controller and all is right up here. That's the throttle linkage right there. The engine is fuel injected, like most of the engines back that time, even the American stuff. But this thing is fully automatic. There's really nothing for you to do. We don't have a mixture control. All you have is a throttle and a different way to work the prop, which we'll talk about a little bit. So this does its own thing. You just there's a lever you shut the engine off with, and when you put that back to run, when you start it, it runs. It does its own thing. You don't have any control of the mixture or how it works. It's all totally automatic. It's really, for 1935-ish design, it's pretty far ahead of itself out there. But that's German technology and engineering. They kind of had it going on. Couple new modern things we have on the airplane just for safety and reliability. That's an alternator, which they didn't have back then. They would have had a generator. But you see the exhaust stacks too here, how dirty they run. Because these cylinders are on the bottom, they do collect a lot of oil. They also tend to want to run really rich on the ground. It's happier in the air when it's flying. So you can see all this black soot on all but the very front exhaust. So that just tells you kind of how dirty it runs and when it's on the ground. You also have a spark plug cleaner in there, which I'll show you about as well, which really richens the engine and puts a lot of fuel in there to help keep from fouling the spark plugs, or when they do, you can kind of clean them while the engine's running. Go down here, down the bottom, and there's one of these on both sides. But this is the coolant radiators, and this little door right here, when you open these in the back, this also opens up. It's just a short one, but you got to let more in if you're going to let more out. Just want to make sure that's clear. That's about all to see from there. There's and really on that whole next wing around to the back side, there's really nothing different than it's on the other side, and actually even less. So just so you can see what's over here, here's the coolant doors again on the flap. Nothing's coming off over here. There's nothing on this side much to look at. It does have a step and a handle, but there's nowhere to really step there with no non-skid stuff. There's your electrical outlet to plug in a GPU. That's about all it's to look at here. Going around the other side, we're working our way around. You see how small the vertical fin is. The rudder is not too bad, but the vertical fin is small. The rudder probably could be a little bigger for what you need. It's fine in the air, but on takeoff, you got to be careful. With torque and all, you ease the power up like a lot of these airplanes until you kind of get moving. You have a lot of elevator. It's a very nimble airplane. You don't have to put a lot of input in to get a lot out, much like the Spitfire is. It's very comparable to the Spitfire in flying when it gets in the air. Tail wheel is a locking tail wheel and a swiveling tail wheel, but it doesn't swivel all the way around. It only goes 90 degrees either way. That's why this tow bar is here handy. So even when you're pushing it back in the hangar, you have to put the tow bar on it to kind of steer it, because you can't let it go all the way around because it'll just hang up or break. You lock the tail wheel for takeoff, and it stays locked till after you land. That's about it for the back. So now we're getting ready to get in. The canopy here, if it kind of looks pretty stout and maybe even heavy and maybe well overbuilt, that's because it is. It's very heavy. It's a little disconcerting the first couple times you close it, and then you feel like I don't know, you're just really boxing yourself in. It's really heavy. You don't want it to drop. This window right here actually is on each side. This window right here will open. This little clip right here, you unclip it, and then that's a knob right there. You can grab the knob and you pull it towards you and slide that whole window back to this square. So this whole square is open. I have not had good luck with that window. I try not to open it because it doesn't close easy. It takes two hands. You got to hold it in and clip that clip and a lot of times that clip doesn't want to stay. It'll pop loose on takeoff, which I've had happen, and the window wants to open. So I try to make sure it's secure and leave it alone and use it for an emergency only if I need to. And I probably won't go fly unless I make sure I get it secured good before I go. Same thing on this side. Here's the latch for the handle, for the canopy. You push it forward and you get a pin that comes out there, and on the back goes into 2 holes down at the bottom. Just talking about the fueling. You put the fuel in here, but the way the hose is set up in there, you can't see down in there. So you don't really know when it's going to come up, and it will just come rush back on you and come out. You have to go in here. This little panel right here opens. You clip these 2 little clips right there, and it folds forward. And inside there, this is looking inside there with this door right here folded forward. There's another door. You got a little storage area back in here. You can see it says dipstick inside. You flip this up, and there's a little sounding rod in there that you pull up, and it's a dipstick for the fuel. It's really hard to see, but it's really to do it in any kind of timely manner. It's a 2-person job. You have 1 person here holding the dipstick and keep dipping it and seeing how it comes up, while the other guy is slowly filling it. So it's a 400 liter, which is 100 right at 106, 105.6 gallons. So that's what you have to work with.
Mike,
Yeah.
The airplane burns 100 low lead nowadays, but the Germans didn't necessarily have access to fuel that was that high an octane rating during the war.
Right.
Are you aware of any performance advantage or anything that 100 low lead has given the airplane?
No, it could take 87 before. Back then you take what you can get, but that's all we can get now. But I've never flown it or have heard of any difference in performance. I don't have a real answer to that. I don't know that there is any, or I've never heard of any. So now we're in the cockpit. We got our fuel. We'll just kind of do a quick look around the basic stuff, and then we'll kind of start looking from the left side and just do a sweeping thing around. But I'll show you a couple things here in the center. This is your altimeter. It's in kilometers. Someone before we got it was kind enough to put some actually altitudes that you could recognize and know where you are on the outside. So the needle will come up to there. So you're 900 and it says 84 feet, and then 1,640 feet. And then when it goes all the way around, then you go by the black numbers. So it took me a couple of flights to figure that out, but who did that? But anyhow, that's in kilometers. There's your radio compass, or whiskey compass, attitude indicator, airspeed indicator is in kilometers. I've had a lot of people say, why don't you change that and put it in knots or whatever? Well, it's just a number. Numbers are relative. The books are all in kilometers, so then you got to go convert everything. So you just use the numbers. A number is a number. So we like to leave them original, and there's no reason to change it. This is your manifold pressure gauge, which they use atmospheres as their boost, what they call it. So basically, 1 atmosphere is roughly 30 inches of manifold pressure. It would be standard. The standard day, standard temperature is 2992. So roughly 30 inches would be 1. We take off this airplane at about 1.2. It can be pushed up higher. This is the numbers that came with the airplane that they recommend that we fly it with, so that's what we do. Tachometer right here, the max is 2600. We'll talk about how we manage that in a little bit. Now, this is a little bit different, or actually very different. I've never seen another airplane like it. But this is how you set your prop for takeoff. It's a clock, and you want it at 12:45 for your takeoff. What that does when you do 1.2 atmospheres for power on takeoff, that gives you 2,600 RPM. So, so there's some math to do. If you're going to change those numbers, you still have to make sure you don't go over 2,600 on takeoff. So you have to adjust your, if you want more power, you have to adjust the prop pitch. And you take off in manual. So that's what you're setting this in manual. It always shows you what the prop pitch is, but by reference of a clock face. So when you go to auto, it'll spin to wherever it's going to go. It doesn't really mean a whole lot to you then when it's in auto. It just, you know where it is. So when you come back out to go manual, you know where to set it. Fuel gauge. This is your liters, 400, 300, 200. You roughly have about an hour and a half of fuel where you want to be on the ground, when you come back in an hour and a half. It'll probably fly a little longer. Depends on how hard you're pushing it. If you're doing a lot of formation stuff or photo flights, that kind of thing, you might use a little more. Well temperature, cooling temperature. Those are very big items, particularly the cooling temperature. You really have to watch that. That can get out of hand pretty quick. Fuel and oil pressure. So we'll go into some of this stuff a little bit detail. We're going to start back over on the left side and work our way all the way around to the right. So these wheels right here, the inboard one is your trim, and the outboard one is your flaps. So you set your trim here. It's hard to see, but there's this little hole right here has a little rolling thing with numbers on it. You'll be able to see it here a little better in a second on the next slide. This is all the chains for the flaps, trim. Tail wheel lock is right here. You see the cable goes back there. It's unlocked right now. You push it forward and down, that little ball in it just pulls the cable and unlocks the tail wheel, which is for taxiing around, it's always unlocked. It tends to want to go straight when it's taxiing anyway. We'll talk about that. This is an air exit. You open this. You've got incoming air vents in the front, so it has to have somewhere to go. So you got to open these rear ones also to get the air to come in the front. It probably would, but it will flow much better if these are open. This down here is the primer, and just going to show you a closer picture of that, but it's just so you can see where it is relative to where we are. This is the primer right here, and right there is the trim. There's a 2 there. It goes by number. You set it to like 1.5 up for takeoff. So that's the trim number. The little wheel you'll see move when you move the trim wheel. This primer box right here, the Germans did this a little different. Several of their airplanes were like this. This is a container, and this is a cap. You pull this cap off, rotate this and pull that off, and you pour fuel in there and you fill it up. It's a box, a container of fuel. So this is your primer. It's self-contained, has the fuel in it that you put in it, put the cap back on, and it's ready to go. This is your primer knob. After you do that, when you're getting ready to start the engine, there's another lever up front here. That's what this is talking about, primer lock. You have to reach around here. You can't see it. You can reach around there and you turn the lever forward. So what you're doing is you're opening that line, that primer line to the engine. And you have to remember to close that after you're done priming, because you don't want it pushing fuel back into the primer, which it will do. So you open that lever up front, start pumping. I think you prime it 6 times, and then on the right side you run the boost pumps for a couple seconds each. I'll show you those when we get around there. And then you prime a few more times, close the lever, the fuel line to the engine, and you're ready to start. I didn't get you a good picture of it here, but this is where you flip the, it says manual right there. There's a switch there, forward and back, just for auto or manual for the prop. Actually, that's about how it looks when you're flying it. You really can't see it. You got to just feel for it and know it's there. This is the friction lock for the throttle, which you'll see better here in a second. Here's the throttle. Here's the friction lock I was talking about. Fuel selector here. It's basically just all the way up is on, all the way back is off. This right here, this toggle switch right here is your prop. That's what you're controlling that clock with, and your prop pitch when you're in manual. When you're in auto, it doesn't do anything. So while you're in manual, you set the prop where you want it, which is 1245 for takeoff, and you crack the throttle up.
Mike,
Yeah.
we're getting a little bit of degraded audio quality. Did you perhaps move further from the microphone?
Get further? Yeah. Okay, is that better?
Yep, I think that's better.
Sure. So that's how you control your prop with that little toggle switch right there. I see emergency canopy release, which is right there. You just pull that lever and the whole canopy, including that back piece of glass, goes off and leaves the airplane if you had to get out. The landing gear system is all right here. This down here is not normal. They put this in there just as a safety feature for the airplane, as a modern addition. When it's pointing down, this right here is a lever. It's pointing down, it's ground, and when you take off, you swing that lever over to this way to divert the hydraulic fluid to make sure it goes the way you want it to go, and then you push up. Or when you're going to land, you swing this down and you push down. These are your lights. The green lights are at the bottom. The unsafe lights are up top. There's a hydraulic gauge right there. And after you start, before you taxi, you want to push this down button while this is down and have at least 500 pounds of PSI on the gauge before you taxi to help shore up the gear, so it doesn't collapse when you're taxiing. It's locked. It is locked on its own, but this is just a backup to make sure that nothing like that happens. Going over to the mags, the mag switch here, it's a little bit different. A lot of the foreign airplanes are like this. They have mag 1, mag 2, and then 1 and 2. The US stuff is left, right, and both. That's basically what you have here. This little chain right here is a key that fits in there with 0, and that's the only place it'll go in or out. And then you can move it up to whichever mag you want. And of course, you run it both. This is a starter selector right here. It has an inertial starter, so you have to wind it up first, but it has this big heavy clutch on it. You let that motor wind up. There's no indications inside of how fast that motor is running up. You just hear it. So you hear it wind up when it stops accelerating. It's spring loaded to the center position, so you have to push it in. It'll spring load back out to the center. And then when you're ready to engage it with the prop, you just pull it out and it engages with the prop. And if it doesn't start, it'll just turn the prop until the motor slows down and stops. And then you have to basically do that again. And but normally if you have it prime right and the mags are on and it's got plenty of fuel, it'll fire up and go just like that. This is the spark plug cleaner I was telling you about. If it starts running rough when you're taxiing out, or even before you take off, you'll usually do it on the run up anyway, just to make sure they're all cleared out. 18 to 1900 RPM. Pull the spark plug cleaner. Makes a nice little show thing too, because it throws out all kinds of fire and smoke and stuff, and sounds terrible running outside. But you're making it do that, and it does clean the spark plugs, and it does help. And there's no real limit on it. You just use it whenever you need it. I like to do it before I take off, and I like to do it when I come in right before I shut down. But there's no rhyme or reason that they tell you when you need to do it or should do it. We've pretty much gone through these center instruments. Look at the pedals. They're a little different than American airplanes, where you're always told in a tailwheel airplane, the heel's on the floor, you basically fly with the balls of your feet. The Germans never really subscribed to that. They want your whole foot up on there, and you move your whole leg in and out. It took a little bit of getting used to, particularly with the tops of the pedals being kind of back. You have to kind of get used to holding your ankles in back so your feet are off the brakes. It's never a real problem because the brakes on these airplanes were never really that great, but it is something you have to watch out for and get used to, using your whole leg and having your heels actually up in a stirrup. The emergency gear release right here is just a mechanical cable that if the gear didn't come down on its own, you just pull that and it releases the up locks, and the gear will fall down on its own. And you rock the wings just to get them locked in, and they do have a lock. There's the vent to come in. Yeah, I showed you the vent that went out on the other side. Just a little better shot there of the pedals. Yeah, your heel of your boot sits in that pedal. A little bit different feeling. That actually, they normally have a strap across there that straps your foot in there, so you actually can pull on it as well. Another modern thing they put in here, because the old original type circuit breakers were not very reliable. So they put modern circuit breakers in here basically as switches to just run your pitot heat and your lights. And these two are your fuel pumps right here. And each one will turn that light on. And that's the fuel pumps you run for 2 seconds after you prime it 6 times, and then run this for 2 seconds, then you prime it a couple more times. And then you just have these on takeoff and landing. Otherwise, they're off. Right down here is where you operate your coolant doors. And there's open, closed, off, which is a center position, so you can stop them where you want. Or there's an auto mode. The auto mode, I haven't found anybody could really tell me how it works yet, and haven't seen it written down. But when I've played with it, because all the pilots I've talked to only have flown an E model, and they didn't have this auto mode. So experimenting with it, I think it works more like a Spitfire. And back then, I think auto meant something different than it does today. I think their meaning of auto is when it gets hot, it will open the doors. They'll stay where you put them, but if you go to auto, they'll stay there until it gets to the max of hot, and then they'll open. But I don't like to let it go that far before I see what it does. So I usually just do it manually, and it works fine manually. They're actually compared to a Spitfire, this is much easier to manage the coolant temperatures in this airplane. And again, that's hydraulically operated. And a little bit further back, there's just your master switch and alternator and a voltmeter and your headset jacks, and that's pretty much it. That's back here. And then you're ready to go fly. So, like I said, we're very fortunate to have the maintenance folks that we really need to operate this airplane, even though we don't really go anywhere in it. We always come back to base just like the Germans did. It's you have to have a ground crew really to operate this airplane. When you go to start it, if it doesn't catch and start that first time, somebody has to go and basically unlatch that starter from the prop. It stays engaged. You have to pull the prop back probably maybe an inch, and you'll hear it click, which is when that tooth comes out of that starter, and then you can wind the starter up again. If you don't, it's still engaged with the starter. So it takes the engine to start to throw that thing out. So if it doesn't start, somebody has to get out. And if you're by yourself, that means you have to get out, walk all the way around, pull that prop back a little bit, go climb back in and put all your stuff back on. So again, it's just another thing of not a good idea to really go off somewhere with it by yourself. Fighter Factory does a really good job in taking care of this stuff for us. They know the airplanes inside and out. So we'll go through a start, and then we'll be ready to taxi. So basically, your battery on. If you're going to use a power cart, you can. Here's the mags where you can see that key is in there, and it's not hanging there. And now after it's in there, you go all the way up to 2. You just turn the mags on. You do your prime sequence that I was telling you that you do, and that's pretty much it. Push it in to wind up the starter, and when it's wound up, just pull it out, cranks, and it fires up, and that's pretty much all you do. It's ready to go. Like I said, there's no mixture, there's no prop lever or anything like that. You do have your prop already set at 12:45, and you're ready to go till after you take off. So they pull the chocks, and that's basically it. You're already ready to go. There's not much to do after you get it started, but start the taxi, except push this in before you go. The gear down. Make sure that lever's down. Push that down to get 500 pounds on your hydraulics, and just for backup. Nothing should happen if you didn't, but it's just a backup. So taxiing, it tends to, the only time it really wants to go straight is when it's taxiing, because when you get power up on it to go fly, it wants to go everywhere but straight. It tries to. You kind of have to use a lot of power and brakes to turn sharp, and one way more than the other way. Usually, it's that tail wheel. It's the same tail wheel that's on a Fw-190, and it's the same way. Even though it's unlocked, its angle, it doesn't really want to turn, so you have to kind of add power, push the stick forward, which kind of goes against the grain for tail wheel pilots, to get a little weight off of it, to get it to start around. And when it turns, after it goes okay. So you get it out there, get it turned, and go in the direction you want. It's not bad after that, but making sharp turns is a little bit of work. And that's pretty much on taxiing. It's just got to kind of have to manhandle it in the turns till you get out there. Taking off, again, you're pretty much ready. You do run up at 1900 RPM, check the mags like you would in anything else. While I have it up there, I'll go ahead and clean spark plugs just to make sure that they're all firing good before I go. And line up, lock the tail wheel, and bring the power up to one atmosphere, and just let it start rolling. As it starts rolling, and you feel comfortable going a little more, you're really not far, really from full power. This supercharger is kind of on a barometric clutch, so it kind of starts kicking in as you're giving it more, but you're not really going very far with it before it really starts doing this thing. So you have to really be careful how fast you go. By throttle position, you're not very far from full takeoff power, but it's not moving very fast. But the more it gets moving and the more air it gets in there, the more power it gets, and it starts accelerating a little faster. So at 100 kilometers, which is only about 54 knots, you just ease the tail off, let the tail come up and just sit a couple inches off the ground, and just wait. And bring your rest of the power up to 1.2, and you wait and let it do its thing. It'll fly when it's ready. It always gives itself, 3 chances. You watch any 109 taking off somewhere and they'll do a bounce. They'll bounce twice, and then the third one, they'll kind of hang there, and then it goes flying. It's just part of the 109 way it does things. If you try to not let it bounce, you're really slow, and just let it do its thing. It will do it, and it actually handles pretty nice in the takeoff. You can't see out front at all, like most tail wheels, but this one just seems to be a little worse as far as being able to see where you're going, taxiing or the initial part of the takeoff. But just let it take off itself, and it's pretty docile there. Another thing about this thing, I have never found that it is as bad as all the stories I've heard, but I have pretty much always flown it off of grass, and that's pretty much what the Germans did, was mostly off of grass, and it's not quite the monster that I was expecting until I put it on pavement. And that was another whole thing. It will go everywhere but where you want it to go, and the thing you got to do is just try to get it stopped before it does something else. You're not going that terribly fast anyway. It's a pretty nice airplane as far as flying slow, and it will fly slow, and but it likes to go somewhere other than straight when it's on the ground. After you get in the air, you let it accelerate, then start bringing the gear up. You can see the coolant doors are all the way open right there. You see how wide open they are. Flaps are still at 20. You take off with 20 flaps. But you can see the torque, you can see the rudder there, the ailerons, trying to keep it all going straight. But it's actually flying pretty nice right now. It's slow to accelerate, but when it gets up to speed, it likes to go fast. It's a smooth, clean airplane when it gets up there. One of the biggest challenges I found initially was just getting it slowed down, getting it in the pattern, because it wants to go fast, and you're trying to go downhill at all, you can't get it slowed down. So there's a little bit of management there, just because it was so sleek and it likes to go. As soon as you get the gear up, you basically just switch the prop to auto, and it'll go from its 2600 down to 2300. And then all you have now to control anything with is the throttle. That handles everything, the prop, your mixture, everything. So that's all you're doing, is just driving the throttle. You don't have to worry about the prop anymore until you come back to land. Now, where that might change, and if you're doing some formation work or some photo flights, it's a little slower to respond, the prop is, with the throttle for those needs. So I usually go back to manual and set the prop where I want it, about a 130 on the clock position, somewhere in there. And then you have good positive speed control in those situations. As soon as I come out of that, you go back to auto, and you just fly it till you get in the pattern. And there it is, clean with everything closed up. Those aren't all the way closed, but it would have to be pretty much in the winter time to have those doors all the way closed, because there always needs to be some air going through there. But it cools down pretty good in the air. Again, there's the door for the oil cooler, and that just does its own thing automatically. Tail wheel does not retract like it does on FW-190. No other thing really in the air that you need to see. Here you see the trees are moving fast, but coming back around the land, like I said, basically learn to get it slowed down, and everything is in reverse. What helps you slow it down is to go back to manual on the prop, start working it back to its 1245 position, which is a higher RPM, and that'll help slow you down. And then you start getting the gear down, and the flaps down. The flaps again are manual, so you're really there's a lot of strokes in that wheel to get the flaps all the way down. It's actually a lot of work. You kind of have your hands full on final or base turning final, putting the rest of it down. But after that, it's really docile airplane down to the touchdown. It's very light on the controls. You have plenty of control to do whatever you need, all the way into the flare and a nice 3-point landing. And on grass, it's I want to say it's a non-event because you're certainly on your toes with this thing, but because it can do anything at any moment. But it's not that bad. You're not going that fast, so it's in a matter of a few seconds. It's kind of all over, and you're good. It's not too bad in the crosswind. Not like you would think. The Spitfire, which you saw in there a little bit earlier, has narrow gear like that, and it looks like it would be very unstable on the ground. But the Spitfire is very, very stable on the ground. Really wants to go straight. It doesn't seem to care if there's a crosswind or not. No matter what it is. So this is a little different because those tires and those wheels are canted the way they are. And some of what that issue is if you get weight over on one of those wheels because they're canted like that, it tends to want to dig in and pull you that way. And when it gets to a point, one would think you'd pull the power off to stop. Well, that makes it worse. So you've already got power on there. You're better to try to fly through it than try to stop. And of course, like all tailwheel airplanes, that you just try not to get yourself in that spot. But if you let the airplane just keep the tail up, come off a small amount, and just let it fly itself off, you usually don't have this problem. Just where you get really heavy weight on the wheels, and particularly one wheel, is where the issue comes in. Taxiing in, basically the same thing. You got to run it up to clear it out. I usually do the spark plug cleaner again, and if it's running hot, you can't have it over 115 degrees. And this is where it's a little different than the Spitfire, which it's only going to continue to heat up. But in this airplane, if it's running hot before you shut it down, you just pull the power back to idle or just above idle, and you wait till it cools down, which is almost unheard of in a water-cooled airplane. But it actually does work. It actually does cool down when you pull the power down in this airplane. Can't think of anything off the top of my head about that. One thing about that canopy in that window is we did have a coolant line come off one time, and I ended up with mist of coolant inside. And that side window, this canopy is not set up so you can open the canopy like you could in a P-51 or a Spitfire or anything that slides back. So you can't really open it when you're flying. And opening that door, I didn't know if it would help draw it out or if it would draw more spray inside or mist inside. And then I'd have to deal with the window. So that's one of the issues with that window setup, is why I leave it alone, because you don't know what you're going to have if you open it. And now you're already dealing with having to get back on the ground fairly quickly, and the window is open and you want it closed and you can't get it closed because it takes two hands and you're already busy just trying to get back on the ground. Those are the only real issues I've had with the airplane. It's pretty reliable and fairly straightforward when you get to know the systems and how the Germans were thinking when they did all this stuff, because a lot of it is automatic, and which is what really basically makes it different. But it's a great flying airplane in the air. It's very nimble. It can certainly hold its own on the Spitfire. We have a Spitfire pilot here who thinks that that's not the case, but he hasn't flown the 109 either. So anyhow, I've flown them both, and they're both really, really close in what you can do with them. That's pretty much all I have. Anybody have questions?
Mike, you better believe there are plenty of questions that have been asked, so I hope you're ready.
Answers. Go ahead.
Okay, we've got a lot of questions about the view from inside the airplane, in terms of not just the looking out over the engine to the forward
Sure.
section of the aircraft while in flight, but also visibility to the sides and rear. Seems like it would be dramatically less than it is, say, in the Spitfire or the Mustang.
No, I can see why you think it would look like that, but it's the windows, while they're square. I mean, it's a square-looking canopy. Um, it, they're fairly close to you, so I mean, you can pretty much see anything you need to see, like any other airplane. I mean, there's some posts in there, but they don't really affect you. Um, the other thing I did forget to speak of is the small cockpit. And I'd heard that, most of my flying career too, till I got in one. But I found that the FW-190 was smaller and a little tighter in there than this airplane was. It getting in this airplane, it's tight, but when you're down in there, it's really not bad. It kind of opens up inside, and you do have a little bit of elbow room. When you get to the switches that are behind you is where it's a little bit difficult. The battery switch and the alternator, getting back behind you, you're kind of doing it by feel, but um, but the visibility is actually not bad at all.
Got a couple questions here about the aircraft's handling characteristics at high speed. Is there a speed at which you lose the ability to, drop the flaps or open the coolant doors based on the lack of a hydraulic assist? And is the airplane especially heavy on the controls at high speed?
No, it stays pretty light. No, the coolant doors you can you can use at any speed, but typically at a higher speed, you're not going to have them open or open far. But there is no speed limit on the coolant doors. The flaps are at 250, I think it is, 250 kilometers to start them down. So,
Mike, we've got a lot of folks asking if the airplanes, since we have both a Spitfire and a 109 here in the flying collection, have the pilots ever been tempted into a mock dogfight?
oh no, we would never be tempted to do that. Yes, of course.
And given that such a thing would never happen, who won?
Well, it depends on which airplane I'm flying. I
Chief
hope
pilot
Johnny
always wins.
knows. That's right. If they know what's good for them. No, so that's why I was saying that it is. They're very close, and I would have to say I've had the opportunity to fly the Spitfire a lot more, and feel where its limits are, and than I have with this airplane. And I, I think the Spitfire might hang in there a little bit longer, but um, I haven't flown this airplane in the manner I've flown the Spitfire, to say for sure, and it has as much time in it to feel. But it really does hang in there. We have played around with it a little bit, and you're not going to lose it. You can stay with the Spitfire, and the Spitfire, can stay with it. So they're very comparable. This airplane will outclimb the Spitfire, but they're very very close. And I think that's one of those situations where they come in, pilot training back then, and not all battles were won by the best airplane, but you could take an inferior airplane with a very well trained pilot, and come out on top.
Mike, there's been quite a few questions asked for clarification on the subject of its infamous landing traits. You mentioned that those really come through when the airplane is operating from pavement as compared to grass, and aircraft like the 109 is kind of why we have a grass strip here at the museum. They're just more comfortable that way.
Yeah.
What is it about the pavement that makes it so troublesome and so risky to fly this airplane?
So you don't really see it when it's on grass, um, but it's giving a lot. It's sliding a little bit. I mean, a minute amount, but it's not. When you land on pavement, when that rubber hits the pavement, it if it's not perfectly straight, or if you got a crosswind, and it starts putting a little weight on one gear, it can't like slide a little bit and kind of get past that point. It's going where it's going because it's got good contact with the pavement, and it's stuck. Just like you jump off, you have a good pair of sneakers on a basketball floor. You're not going to slide. You're going to stop, and that's same thing with this rubber does on pavement. So you really have to stay ahead of it, and sometimes you just don't have enough to stay ahead of it. It's a handful. It really is. It does. There's no forgiveness in it. With on grass, it kind of just tends to sort of slip its way through those things and tend to still go in the direction that it's going. Where on pavement, it's going to go where the tires feel like the direction they need to go. And which with this gear canted the way it is just makes all that happen. If they were straight, like the Spitfires are up straight, you wouldn't have those issues.
It's certainly an interesting thing to look at, design wise. Had pilots been consulted, that might have been something flagged earlier in the process. But Mike, when you and I have talked about the airplane previously, it's appreciably tight. To get in the airplane, one of the things that people are kind of surprised by coming here to the museum and seeing it alongside other World War II fighters is actually how small and low to the ground the airplane is, and how narrow the fuselage is. Can you describe that tightness inside the cockpit in a way that maybe folks who haven't been able to see it in person can kind of understand?
Yeah, it's like I said, it's a little tighter to get down in it because the tops of the where the canopy comes down, that's a little closer in than the roundness of when you drop down in there. After you're down in there, your shoulders might be touching a little bit on the sides, but inside you have room to move around a little bit, and you do kind of have your knees up at your chin, a little bit. Kind of it's a little bit different seating setup in there. I find that they're really not adjustable much, but the pedals are too close for what I typically like. But the seat isn't adjustable. It is small in there, so you just have to kind of manage what you have. And, these were 20, 22-year-old kids that were, young and small. It probably wasn't that tight to them like it would be to me.
Mike, can you talk a little bit about compensating for torque at low speeds in this airplane? That's a common challenge that you find with all of these, piston-engined aircraft, but could potentially complicate things in a 109. Can you maybe describe rudder usage on takeoff and so on?
Sure. You mainly bring the power up. And it's kind of not as bad in this airplane because of the supercharger. It just hasn't really spooled up the engine yet and hasn't started moving. Yeah, this airplane doesn't seem to accelerate quickly like I'll just use the Spitfire for an example. That's not a quick accelerator either, but you just feed the power in slowly till you get moving, so you have some rudder authority and you can feel that it's working before you start pushing it all the way up there. So you're kind of managing the torque with how much airflow you have over the rudder to compensate for it. And if you go a little too far with the power and you feel it's turning a little bit, I don't ever pull it back. I just stop going up until the speed catches up with it. Then you have authority again. You're talking about very minute seconds, but you can feel that happening. But you'll catch up speed wise to that, and then you can start going forward again.
There's a couple folks asking how you learned to fly the airplane. Was it primarily through translated German manuals? Is there a set of post-war pilots that were able to share their information with you, or did you benefit from the various German veteran pilots from the war that have actually visited the airplane and visited the museum over the years? And if any of those folks had pointers, would you share them with us?
Um, a little bit of most of that. I talked to pilots who have flown them, and Rick Volker, who the first picture I had up there, who came and flew it for us initially. Um, I soaked up all he could tell me about flying it. While he'd only flown a E model, they are different, and I found out, and he found out. This was the first G that he flew. Um, and you just kind of take it all in. We have checklists, and there are manuals out there. You get online and you read, and um, you talk to any pilot that you can find that has flown one. And there aren't too many guys that were flying them back then that were around. We just lost one recently that was at the museum, but you just take it all in from anywhere you can get it. Anybody that's flown one, and try to put it in your brain as something in some logical order that you can use. But nothing really teaches you like when you get in it and go, because there's so many different things in a new airplane. You got a totally different engine that you've never flown before, type engine. Most of the American fighters and all have, or even British fighters. There's only a certain number of engines that were used in many airplanes. So you can fly a lot of different airplanes, but only 3 different types of engines because they're all the same. But this is totally new to me, this Daimler-Benz engine and how it operates. And but on the first flight, you're trying to get what it feels like, what the airplane's feeling like, what it's doing. Is it happy? What's normal with the engine? You don't really know what's normal yet because you haven't seen it. I mean, people can tell you, but you have to see it and feel it for yourself. And until you get up away from the ground, get the gear up and get up there and kind of go, okay, I think I got it. It's just different. You have to do it, but it's a pretty cool feeling to feel that something like that you haven't felt before. Flying an airplane is flying an airplane, and it's all numbers. But knowing where to look, which gauges to look at, when you need to look at them, because they are different, and sometimes they look different. Even though you've studied the cockpit, you've sat in it, taxied in it, and like these airplanes, you can't taxi them but so much they overheat. So and then you're just ready to go fly. There's nothing else left to do. But that's pretty much it. You just kind of take in all you can, and you got to go do it.
Mike, we've had a few questions asked about the airplane specifically. I think this is somewhere that I may be able to help kind of clarify the journey that our airplane has been on. Work on the airplane began originally in 2005, and the airplane first flew in 2015. The team that restored it from Meyer Motors spent 10 years working on the airplane, though they themselves would describe it as some work, but a lot of research and sourcing parts. They also spend a great deal of time over in Germany talking to the fighter aces from the war, the guys they called the Alten Adler, the old Eagles. So there was a lot of input into the development of this particular restoration from Luftwaffe aces during the war. Our airplane is registered as a 109 G4 because it met the burden of proof to reassume the serial number 19257 established by the German government. So it uses parts from a couple of different sources. The wing, there is a wing and a wing bridge section from a Buchan, which is the license-built Spanish version of a 109 G6. But the majority of the other components actually came from 19257, an airplane that was lost on the Eastern Front, as I understand it. There were several other aircraft represented in the parts stockpile that were recovered from battlefields on the Eastern Front. There are a couple of other airworthy 109s. There's one at the Flying Heritage Collection, and I believe there's one at the Erickson Collection. Though they do grow there are more and more in restoration and being developed. It's a very rare airplane. It's something that's very special that we have here. An interesting story that I would share with you all is that our airplane has a DB-605B engine instead of an A, which actually came out of a Bf-110 during the war. The reason this is interesting is the particular aircraft that was the originator for our engine was actually landed by mistake in Switzerland, and it was equipped with a whole bunch of German night fighter radar technology that they were using to look for Allied bombers at nighttime. The airplane landed in Switzerland and almost caused a massive diplomatic incident because Allied agents were immediately interested in getting a hold of the German radar. The Germans made plans to bomb the field where the airplane had landed, threatening Switzerland's neutrality. What ultimately happened, though, on May 17th, 1944, was the Swiss destroyed the airplane by use of explosives. Interestingly, few weeks later, they received a shipment of factory fresh 109s from the Germans as a gift, seeming to suggest there had been some prior coordination and exchange for destroying said Bf-110. But before blowing up the 110, the Swiss had actually saved the engines off of it in anticipation of needing spare parts for the 109s they were to be gifted. So ultimately, it was purchased for this project in 2012, but it still has its Bf-110 gearbox because when Mike Nixon was working on the engine, he determined that it was in perfect shape and it made little difference to the overall performance of the aircraft to keep that original gearbox. So we continue to operate this with a war veteran DB-605B engine in it.
Okay, and that's why you are a museum director and I'm a pilot.
As I said, I'll happily step in to help with that particular question. I think
Yeah.
it's something we do get asked a lot because there are airplanes out there flying that are the Hispano-Suiza Bouchons with Merlin engines in them. That's what it was used a lot for the filming in the Battle of Britain and so on.
Right.
But like I said, ours has parts from a Bouchon, and if you really know what you're looking for in terms of structural riveting and everything, you can see that in the airframe. But again, it did meet the burden of proof to reassume the serial number of an actual wartime 109, though it is not painted as that particular aircraft.
Right.
Just looking through the questions here, folks, if you have additional questions, do please take this opportunity to enter them in. Mike, we've got a lot of people asking how tall you are on the basis of the discussion about, having your knees up to your chin inside the airplane.
That might be a little exaggeration, but my feet are closer to me than if I could set them, then I would have them set. I'm 5'10", but it's a small cockpit. I mean, there's not a lot in front of you behind that instrument panel, so it's short down there. It just I like to have my legs stretched out a little more when I can, but these are set so that just feet are closer to me than I would normally have them.
Well, Mike, it does look like that brings us to the end of tonight's presentation. So thank you for joining us tonight, everybody. Again, we do fly these German airplanes so that we can be reminded of the technological advancements and everything that the greatest generation here in the United States was up against. And there's a tendency with some modern audiences to believe that the war was kind of fait accompli, that we showed up and we were awesome and we won. But in truth, we were actually fighting against some pretty advanced adversaries, and airplanes like the 109 help us tell that story. So we appreciate the time that you've all spent with us in this incredible, infamous adversary airplane tonight. If you're interested in hearing the wild sounds that Mike described throughout his presentation, do keep an eye out for our summer of flight schedule. Its announcement is imminent. If you'd like to be the first to know, do sign up for our newsletter. You can do that by visiting our website, militaryaviationmuseum.org. Alternatively, if you'll like and follow us on Facebook, we will post the schedule announcement to our Facebook page as well. I'm Keegan Chetwynd. This has been the Military Aviation Museum's webinar for tonight. A big thank you to Mike Spalding, and hope all of you enjoy the rest of your evening.